This is part of our archaeology playlist by Dr. Chazan. This is his 8th chapter. It's on bounds and maize. He said that maize was domesticated in Mesoamerica or Mesoamerica and was subsequently adopted by societies throughout the Americas. And afterward from this reading, we should understand that the archaeological record of the domestication of maize, as well as beans and squash in Mesoamerica as well. We shall identify the impact of the adoption of maize agriculture on the archaic societies of the southwestern United States and northern Mexico. We will understand the complex interaction between the indigenous domestication of plants and the adoption of maize in eastern North America, and then we will apply that to understand the context of the mound construction of the Adena and the Hopewell cultures, which we have covered in a previous reading. We have sites as well that we're going to cover, and those sites and when they emerged in the archaeological period or the archaeological record. We'll talk briefly about plant domestication in Mesoamerica, and we will mainly be conversing about maize agriculture in the American Southwest. I have already gone over AMS, radiocarbon dating, which is accelerator mass spectrometry. We've already gone over that. It's in a separate video on dating methods in archaeology and history. It is a refined method of radiocarbon dating that makes it possible to date very small samples, including plant remains, and it uses carbon-14. We might go over that briefly and concerning a diagram of an accelerator that is used for accelerator mass spectrometry radiocarbon dating. We're also going to talk about the formative period, and then we're also going to talk about Eastern North America, but Eastern North America will be in our last reading. Right now we're going to mainly focus on maize and agriculture in the American Southwest and plant domestication in Mesoamerica. We have sites that have developed over time. We have the Guila Naquis, which existed from about 10,000 years ago to before 8,000 years ago. They domesticated squash. We're also going to talk about the time in which they domesticated maize as well, all on and up into the we have another Guila Naquis site where they domesticated maize. So they went from one domesticated squash, the other domesticated maize. That existed around 7,000 years ago. And then we get to the Eastern Late Archaic period from 5,000 to 3,000 years ago. And that's when we have the site at Poverty Point in the Americas. We also have, and of course, Gila Nakititz is in Mesoamerica, as well as the Tehuacan Valley. We also have around 3,000 years ago, we have the Cerro Huaneca culture, which is near the middle of the Rio Grande. And then we also have the Las Capas around 3,000 years ago, and Milagro as well. Milagro is up there around the western United States, and of course as well as La Capas. And these cultures are starting to form at the end of the Eastern Late Archaic, and they will be part of the Adena and Hopewell culture, as well as the Southwest Late Archaic, and before we get to the Southwest Formative period and the Late Woodland cultures. As European settlers spread westward across North America, they encountered the remains of massive artificial earthworks. These monuments of a remote and mysterious past fired the imagination of the colonial Americans. The earthworks were astonishing in their size and density. One mound, for example, at Miamisburg, Ohio, was 20 meters high and 200 meters in circumference. In the Ohio River Valley alone, there were 10,000 mounds, and the earthworks were found in a wide array of forms, including flat-topped mounds, conical mounds, and enclosures. Some of the earthworks, such as the Wisconsin effigy mounds, include human and animal forms as well. We could also see the Great Serpent Mound in Adams County, Ohio, which has the figure of an undulating snake with a curled tail stretched over 200 meters long over a hill overlooking Brush Creek. And at the open mouth of the snake is an oval mound. It is interesting to look at from an aerial photograph. Then we have, in the 19th century, the belief was widespread that the earthworks of eastern North America were the remains of a mysterious race of mound builders with no relation to modern Native Americans. But the mound builders were often portrayed as civilized in contrast to the perceived savagery of the modern Native Americans. Theories of the origins of the mound builders ranged from the Vikings to the lost tribes of Israel. But, of course, the fate of the mound builders was imagined as either migration to Mexico or defeat in bloody battle. The idea of a race of mound builders is now thoroughly discredited. But, rather than searching for lost tribes, archaeologists today seek to trace the economic and social context of mound building among the early agricultural societies. Of course, it is very difficult to organize the origins of agriculture in Mesoamerica and North America into a clear set of stages. Of course, because we're still talking about our agricultural section in archaeology and different perspectives on agriculture. So check out the Great Serpent Mound in Ohio. And again, we're covering these cultures. Most of them existed from 9,000 to 3,000 years ago. The picture that emerges from recent research, however, is one of regional variation in the pathways taken in the shift to an agricultural way of life. And perhaps the more surprising and most surprising development is the genetic and archaeological evidence that suggested that domesticated bottle gourds are found in the Americas as early as 10,000 years ago, although a more recent analysis suggests the equally surprising scenario that wild bottle gourds floated to South America from Africa and were subsequently domesticated. But in this reading, we will begin in Mesoamerica before moving to the American Southwest, and then in our second video, covering this chapter, we will head to Eastern North America. Mesoamerica has been studied primarily as the area where major food crops, including maize, squash, and beans, were domesticated. The development of new dating methods has radically altered the chronology for the domestication of these plants. Altogether, we know quite a lot concerning the timing of crop domestication. Many questions linger, however. Currently, we know little about the social context of domestication in Mesoamerica. The uptake of maize agriculture in the American Southwest was geographically variable, and in some areas, large villages with features such as terrace walls and irrigation canals appeared at the same time as the first domesticated maize. However, in other parts of the Southwest, the impact of maize agriculture was minimal. In explaining this variation, archaeologists working in the American Southwest have emphasized the ecological variability of the region and have then developed models based on optimal foraging theory. In eastern North America, for example, we trace a complex situation involving the local domestication of plants, followed by the addition of maize to an already established farming way of life. Archaeologists in eastern North America have suggested many explanations, but have struggled to explain the early and pervasive appearance of eastern mounds long before the appearance of large villages. And again, we have these settlements, people no longer going around foraging, but we have large villages, and not only villages, but these villages will end up sometimes becoming cities, and then the final emergence of empire. But in grappling with the social meaning of these monuments, archaeologists have drawn on a variety of theoretical frameworks to explain these mounds, including agency theory. But we end the chapter by following a debate among the archaeologists working in eastern North America over the question of who actually domesticated plants. The context for this debate is feminist archaeology, of course, but the questions raised do go to the very core of the origins of agriculture, and we probably will skip that part. But nevertheless, we will begin by talking about plant domestication in Mesoamerica. The Pueblo societies, we've talked about them before, of the American Southwest express the centrality of maize or of corn to both their subsistence and their spiritual life as well, with the simple phrase, "Corn is our mother." Maize plays a similar central role in many indigenous farming communities throughout the Americas. Archaeologists and botanists have traced the origins of maize back to teosinte. Teosinte was a wild grass that is found in the highlands of Mexico. Teosinte produces 2 rows of small triangular-shaped seeds encased in a thick glume. Maize seeds are usually several times larger than teosinte seeds and grow in 4 or more rows. Teosinte also differs from corn in that the rachis, or the part of the plant that holds the seeds that we've talked about, is brittle, so the seeds disperse at maturity. The identification of teosinte as the wild ancestor of maize has been of much subject to debate. However, the genetic relation between the two plants is now well established. It is even possible that the shift from the one to the other took place rapidly. Genetic analysis of modern populations of maize suggests that there was a single center of domestication for this crop, and it probably was located in the highlands of Mexico. And again, we're talking about teosinte and maize. Archaeological research on the origins of agriculture in Mesoamerica has focused on the excavation of dry caves in the highlands of Mexico, where plant remains can be and are well preserved. The picture that has emerged from the cave excavations is that plants including maize, squash, and beans were domesticated in Mexico by groups of mobile hunter-gatherers. The domestication of plants appears to have had little effect on these societies beyond providing an additional resource for their subsistence. And however, it is possible that the archaeological emphasis on highland caves has biased our understanding of the impact of agriculture. Excavations by Richard McNeish in a series of caves in the Tamaulipas Mountains and in the Tehuacan Valley, and by Kent Flannery at the cave site of Guila Naquitz. I think it's Guila Naquitz in the Oaxaca Valley have produced a long record of occupation by prehistoric hunter-gatherers who gradually incorporated domesticated plants into their subsistence base. The highland valleys of Tehuacan, 1,000 to 1,500 meters above the sea level, and Oaxaca, 2,000 meters above sea level, have shown might not be the actual location where any of the Mesoamerican crop species were initially domesticated. The sites were chosen for excavation because of their long sequences of occupation and their excellent preservation of plant remains. Of course, the identifiable plant remains excavated at the highland dry cave sites are too small to be dated directly with the conventional radiocarbon dating methods. However, it was possible to date other organic remains, such as wood, charcoal, and to build an absolute chronology of the stratigraphic sequence. The age of identifiable plant remains was then determined based on the level in which they were recovered. Again, we've talked about accelerator mass spectrometry, or which is AMS, and it is also a kind of radiocarbon dating. We've already talked about relative and absolute dating methods within archaeology and history. The stratigraphic sequences at Guila Naquitz and the Tehuacan Valley sites are relatively shallow and compacted. At Guila Naquitz, 5 levels were identified. The top of the sequence is Zone A, a 20 centimeter thick level that dated to a little over 1,000 years ago. Below Zone A is a series of levels labeled Zone B to Zone E, which date between 12,700 and 7,800 years ago. The entire thickness of Zone B to Zone E is approximately 60 centimeters, covering a period of over 4,000 years. And when one considers that plant remains are often extremely small and deposits are shallow, it is perhaps not surprising that the stratigraphic method of dating plant remains from dry caves has turned out not to be dependable. However, the development of accelerator mass spectrometry, or AMS radiocarbon dating, has made it possible to date identifiable plant remains. When plant remains from Huila Naquitz and Tehuacan Valley are directly dated using AMS radiocarbon dating, the ages obtained are often different and in most cases younger than what is expected based on the age of the level from which the sample was recovered. And on the basis of AMS radiocarbon dating, squash has been identified as the earliest plant that was domesticated in Mexico. The type of squash domesticated in Mesoamerica is the ancestor of the vast array of squash that we eat today, including pumpkin, zucchini, and acorn, marrow, and spaghetti squash. Squash seeds recovered from zones C and B at Huila Naquitz have been directly dated to between 10,000 and 8,300 years ago. The seeds are larger than those of wild squash. The thickness and color of the rind also distinguish the domesticated variety from the wild one as well. Again, the Oaxaca Valley is in the highlands of Mexico. It is only in Zone B, which dates to around 8,000 years ago, that there is an increase in the thickness of the squash rinds and a change in color from green to orange. On the basis of these results, it appears that the domestication of squash was a prolonged process that began 10,000 years ago, which is about 8,000 BCE, with the selection for larger seeds. And over the next 2,000 years, farmers selected for an increase in the thickness of the rind and a change in its color. Of course, the oldest directly dated maize was also found at Huila Naquitz. The stratigraphic context for these maize samples is an ephemeral occupation between Zone A and Zone B. Two fragments of maize cobs from this context were directly dated to 6,250 years ago. The maize from Huila Naquitz has a tough rachis and is thus clearly domesticated. It is interesting that one cob has 2 rows, like teosinte, while the other has 4 rows, as is found in most maize. And again, the Tehuacan Valley is a valley in the Mexican highlands where excavations by Richard McNeish recovered some of the earliest evidence of domesticated plants in Mesoamerica. And the Huila Naquitz is a site in Oaxaca, Mexico, that has produced the earliest evidence of domesticated plants in Mesoamerica. And then we'll talk about the earliest maize from the Tehuacan Valley, which directly dates to 5,500 years ago, is of the 4-row variety. The long sequence from the Tehuacan Valley sites illustrates a gradual increase through time in the size of the cobs and the number of kernels. Studies of modern domesticated beans suggest that both common beans and lima beans were domesticated independently in the Andes and Mesoamerica. The oldest direct date on a domesticated bean from Mexico is approximately 2,500 years ago. For a single bean in a cave in the Tehuacan Valley. It is likely that beans were domesticated at a far earlier date, possibly at the same time as maize. Chili peppers were domesticated in either central or eastern Mexico, but the timing of domestication remains unclear. Turkeys were the only animals that were domesticated in Mesoamerica, and it is unclear when the domestication of turkeys took place. Then we have maize agriculture in the American Southwest. Domesticated maize was grown in the highlands of Mexico 6,250 years ago. Maize and squash agriculture spread to northern Mexico and the southwestern United States during the southwestern late Archaic period. The initial impact of maize and squash agriculture varied across the region. In some areas there is evidence of increased sedentism, while in others it appears that agriculture did not substantially alter the lives of late Archaic hunter-gatherers. And of course, I think I'll make this a 3-part series. The first part was dealing with plant domestication in Mesoamerica. The next reading will talk about maize agriculture in the American Southwest. And then, of course, after covering that, we'll go to agriculture in Eastern North America.